We're going to finish up chapter 3, and then we're going to learn a new operator, the is operator. Now, the thing about the is operator is this is the most closely similar to, it is similar to the assignment statement. So how does the assignment statement work in Java or C or C++? What does it do? What does the assignment statement actually do? It takes, what's on the right-hand side of the assignment statement? A whole what? What's always on the right-hand side of an assignment statement? Yeah, an expression or a function call, right? And then what's always on the left-hand side? Like a variable. And what happens is it evaluates the thing on the right-hand side, and then the variable gets that value. Are you with me? Well, that's basically what the is operator does. It forces the evaluation. It's similar to the assignment statement, and the left argument is a simple object. Okay? So we also, plus is addition, minus is subtraction, asterisk is multiplication, slash is division, star star is power, slash slash is integer division, and mod is modulo, the remainder of integer division. So those are kind of similar to the operators that we are familiar with. But these operators actually do the arithmetic, you know, on numbers. Are you with me? Okay, so now let's go to our demo. So check out these demos. What do you suppose happens here if I say x, capital X is a variable, is 1 plus 2, period? What do you suppose is going to happen? Don't everybody speak up at once. Yeah, it's going to be x is instantiated to 3. It forces the evaluation of 1 plus 2, and x is instantiated to 3. Now, is everybody with me on that? Because that's what is does. It actually does the arithmetic operation, right? So now how about this? Capital X is 5/2, comma, capital Y is 5/2, comma, capital Z is 5 mod 2. So what do you suppose is going to happen here? Man, you guys, I wish you wouldn't all talk at once. Say it again. Well, is it be 5 over 2, or do you think this is, which one was the integer division? Slash that. So what do you suppose 5 divided by 2 is going to be? Oh, yeah, I see. In scheme, I guess it was a fraction, wasn't it? Yeah. But here it's not. We don't have those nice fractions like we had in scheme. Is everybody good? And 5 mod 2 is the remainder when you take 5 divided by 2. That's what Z is. Is everybody good with this? Okay. Now, what do you suppose happens if I say, X match 1 plus 2? What do you suppose is going to happen there? This is not is, this is match. No. So let's contrast this with match. Oh, you think no, maybe it'll fail? But X is a variable. I thought a variable could match with anything.
Because wouldn't it? X is 2.5 now, isn't it?
Oh, no. Every query is, oh, goo. No, X isn't that now. Oh, I see what you're saying. No, we didn't define X. No, that's, after the query is done, that's done. We start afresh with each new one. Oh, good point. So now, what do you suppose X match 1 plus 2 is?
Wait, X is 3. Well, X equals 3.
Well, but this is match. This doesn't force the evaluation. Do you see what I mean? So look, it's X match 1 plus 2. Yes, or sorry, X, if we do X match 1 plus 2, it's X equals 1.2. You see what I mean? It didn't evaluate it. It did that. Okay? Is everybody good? And how about this? 1 plus 2 match capital X. What do you suppose happens here? Same thing, right? What about 1 plus 2 is X? What do you suppose happens here? Now, what did we say about the left-hand side and the right-hand side? Say it again. Probably not going to work is right. Because what did we say? The left-hand side had to be a simple object, right? Okay? So is everybody with me on this, on the difference here? Okay? And how about this? Just to show you, X match. Now, watch this. Quote plus quote functor is the functor 1, 2. Now, what do you suppose is going to happen here? You see, the functor's name is quote plus quote. Are you with me? So what's it going to be? No, this is not is. This is not is. Yeah, 1 plus 2. See, that's the 1 plus 2 with the plus in the middle is actually a syntactic abbreviation for the plus functor. Do you see what I mean? Is everybody good on this? Does everybody see the difference here? All right, so let's take a look at the comparison operators. Oops. So look here. In scheme, not scheme, in Prolog, we also have the greater than sign, which means x is greater than y, the less than. The way you say greater than or equal to is you say greater than and then equal to. Notice you don't say equal to greater than. You say greater than equal to. And then equal to or less than is equal less than. And then the way you test for equality is not equals equals, it's equals colon equals. That's if the values of x and y are equal. And then the way you say not equal to, it's equals bash equals y. Are we good with that? So let's do a little demo of that. So check out these. Check out, so how do we do? So if we say 4 is less than 5, what do you suppose happens? Yeah, it succeeds. And if we say...
One above, we have the x plus.
Yes?
X is, or match plus 1, 2. Why is the plus in quotes? Is the special character?
No, Gprolog requires it's like the dot. The dot was another example of a symbol that had to be in quotes when it's used as a functor.
Okay.
When it's used to represent a functor, and plus is like that. Yeah. Did I ever demo the fact that you had to put the dot in quotes? I think we had a slide item that showed the list with the quotes around the dot as the functor. Because a list is basically nested structures, you know. But anyway, it's just some front end syntax that allows us to put the plus in the middle. All right? And then how about 5 is less than 4? Obviously, what's this going to be? Correct. And what about this? 277 times 77 is greater than 1,000. Is 277 times 77 greater than 1,000? Okay, that's a good deal. Okay, now, here's the other thing. We saw on the slide that equals colon equals causes arithmetic evaluation and cannot instantiate. So watch this. So let's do some examples with equals colon equals. 1 plus 2 equals colon equals 2 plus 1. Now the main thing here is it causes evaluation. So what do you suppose? Is this going to succeed or not? It causes evaluation, so it's going to succeed, right? But now let's contrast that with 1 plus 2 match 2 plus 1. Will this succeed? No, because it's like the plus functor, right, with the 2 and the 1, you know, so that's not going to succeed. And how about 1 plus big A match big B plus 2. Can you predict this one? Yeah, why not? So we get, you see how that plus is like, yeah? Are we good? Now, what's the definition of the greatest common divisor? You know the recursive definition of the greatest common divisor? Oh, here's the definition of the greatest common divisor. If x and y are equal, then what is the greatest divisor of x and y? If they're the same number. What's the greatest common divisor of 23 and 23? 23. Okay, so it's x, yeah? Is everybody good? On the other hand, if x is less than y, then what is d equal to? What's the greatest common divisor of, let's see, if x is less than y. What's the greatest common divisor of 10 and 30? Then it's equal to the greatest divisor of what? What's the greatest common divisor of 10 and 30?
10.
Well, yes, but it's the greatest common divisor of 10 and 20. Is that right? Are you with me?
Because then it would do the greatest common divisor of 10 and 20, and then it would do the greatest common divisor of 10 and 10.
10, and then there would be, and the base case would be 10, right? Okay? And on the other hand, if y is less than x, then we do the same thing as in case 2, but with what? But with what? Yeah, with y and x switched. With x and y interchanged. Are you with me? So therefore, look, how do we code? So what's, oh, rats, I gave it away. So what's the base case? If the two numbers are the same, then the greatest common divisor is what? It's the same as them, either one of them, right? So that's the fact. Notice that you don't even need a rule here. It's just a fact. And now the question is, how do we do the greatest common divisor in the recursive case? The greatest common divisor of x, y, d, if what? Now what do we have to use?
To see if x is greater than x is less than y.
Yeah, but what's the case that will stop us right off the bat? If they're what? Oh no, wait, sorry. The base case, oh, you're right. I don't know what I was thinking. I was momentarily thinking we had to check for equality here, but the base case did the equality case, right. So if x is less than y, now what do we do? Now here comes the crucial thing. You have what?
You can choose a variable and say is y minus x.
Yes, we have a new variable, and we say is. We have to actually do the evaluation, the arithmetic evaluation. So we have to have a new variable, and we say is. So y1 is y minus x, and then after that succeeds by having y1 instantiated to that, what do we do?
GCD x, y1, d.
Yes, GCD xy1d, right? And notice that, how do we do OR? We just have a new what? A new rule, okay? So now GCD xyd, and now we say if what? So because if the first one fails, it'll just go to the next rule, right? If the test on the first one fails, it'll just go to the next rule. So GCD xyd if what? Okay, so y less than x, now what? Well, is it, or do we do another is?
Yeah, you define x minus y.
Yeah, but can't we just do this with a one line? Yeah.
Oh,
Yeah, we just switch them on GCD and that's instantiated. Is everybody good? All right. So now let's see. So what happens? So GCD 2033D is going to do what? According to this, what's it going to do? What's it going to call? What will this be? Is this less than this? Is this less than this?
Yes.
So therefore what? They'll call GCD what? 2012D. And then what? Is this less than this?
No.
So it'll call what?
GCD
1220D. Is this less than this? Is this less than this?
Yeah.
So what will we do?
GCD 12,
12.8D. Is this less than this?
No.
So what will it call?
GCD 8,
812D. Is this less than this?
Yes.
So we're saying call. I kind of hate to say call, but anyway, because that sounds like functional, but anyway.
GCD 4, 8.
And then GCD 48D, 48D, GCD 44D, and now what? D equals 4. Yeah. All right. So how would we test this? How would we test this? How would we actually do it? We would say GCD what? If we did that example, we would say 20, 32. And now this is common, you guys. It's common to have, like with these arithmetic ones, to have the query set up so that the thing that you want, the result of the computation you want is the last variable, is the last argument in the predicate. Are you with me? And sure enough, D is 4. All right? Now, here's another one. Check this out. My length. List N. So here's how my length is going to work. Let's see if we can code this up really quickly. My length, L-E-L-E-N-G. My length. Now watch this. Let's do A, B, C, whoops, and then capital N. So what do you think? My length. N is the length of list. Is the length of list. So this should be what? 3. So can we do this? So how can you do this? My length. Can this be a fact for the base case? Or okay, so what would it be?
Empty list, comma, 0.
Yeah, empty list, comma, 0. Isn't that slick? Now there's a paradigm shift for you. You're just stating what it is. And it'll do all the searching for you. And then what? Oh, I should have had you come up with this one. My length. Oh, here's another anonymous variable for you. So my length, any car with tail N, if what? Now, how are we going to do this? We're going to have to do a calculation here somehow, aren't we?
We have a variable is n minus 1.
Yes, we're going to have to have a variable, and we're going to have to compute n minus 1. So that's right. So we're going to say, oh, it's going to call my length tail n1, and it will keep calling itself recursively until what happens? I mean, it will keep. Yeah, it is recursive. I mean, it will keep doing it over and over again, and with tail getting smaller and smaller and smaller till it's 0. So it's my length tail n1, and then what?
N1 is n minus 1.
It's the other way around. Because we're computing, we want n to get the value, and n1 has been instantiated by the time we succeed that goal. Are you with me? Yeah. That was a little tricky, huh? So you kind of have to think about what's going on there.
Can you say that one more time?
Yeah, okay. Let's think about how the searching happens. Let's think about how the searching happens. So what happens is, you see that because up here, what happens is tail is always going to be, tail is in this case, it will always be less than, see this is the tail of the one that we called in this example. So tail will always get smaller and smaller, right? It will keep matching this until it gets 0, right? And then what will happen is this n will be, well, then what will happen is this n1, when it finally gets to the base case, this n1 will have the value 0.
Okay.
Are you with me? And then n has to take that value and add 1 to it, and then that's what this n is instantiated to along the way. Yeah. So yeah, it's a little tricky. All right, you guys. Now, next one is, now this is going to be from the 3rd edition. I need to consult. Now watch this. Okay, now this material, I was disappointed when the 4th edition of the book came out, because chapter 4 of the 3rd edition has this really nice example of how database queries work in Prolog, and I was disappointed that this material is no longer in the 4th edition. So what I've done is I'm assuming fair use here, and so I've made available to you just a little section of the 4th chapter of the 3rd edition online. Actually, some of you guys mistakenly got the 3rd edition of the book, right? So you're safe. You're actually in better shape than the people with the 4th edition now for this material anyway. But this is such a great example of how to query a database, a Prolog database, that I was reluctant to give it up. So anyway, 3rd edition. Now check this out, you guys. Here's figure 4.1 from the 3rd edition. Now look. You understand that this tree, what does this tree figure mean? It means that family is the what? Family, capital lowercase f, family is the what? Yeah, it's the root of the tree. It's the functor of a predicate. Are you with me? And how many parameters does family have? Can you tell from this tree, how many parameters does family have? It has 3, because there's 1, 2, 3. The 3 branches down below. Are you with me? Is everybody clear? And here is an example of the family predicate. And notice it says family parentheses. And now how many items are in this family? It's this, comma, and then this. Right? Now look. And furthermore, the first argument of family, it goes down to here and it says what? Person. So what is person? That's another what? No, it's not a variable. Yes, of a predicate. Are you with me? And how many parameters does each person have? How many parameters does the person? It's a person /4 predicate. Yeah? And what? And so there's four here. So this is a person, this is a person. But now what's this dot? What is this dot? This dot means that's how we do a what? That's the functor for a what?
List.
For a list. Are you with me? So here's the dot for the functor here, but this is basically, this is the list. And what does the list have? It has a what? A car and a cooter. Are you with me? So there's the car and there's the cooter. But now what does this one have? There's the car and there's the cooter. But now what is the cooter of this? The empty list. Okay? But now this dot, we don't use this dot notation. What do we use when we're, for convenience? We use what? The square bracket. So does everybody see that there's the list and there's a list? But now each item of this list is a what? Person. So does everybody see what this family, what this family means? The first item of the family is the husband. The second item of the family is the wife. And the third item of the family is a what? Is a list of what? Children. And each child is a what? Person. So you see, person for the husband, person for the wife, person for the first child, person for the second child, etc. So this is how you could store information about a family. Are you with me? And here's an example of the family whose husbands, now what does a person have? How many members? 1, 2, 3, 4, right? And so what is so it's Tom, Fox. So what is this name? First name. Second one is the what? Last name, the surname. And now what's the third one?
Birthday.
It's birthday. So it's date, but what is the date? How many things does the date have? Day, month, and year. Are you with me? And then the employment status. All right? So works. Oh, I see why this got canned. It's a little politically incorrect to have the husband working and the wife unemployed. Yeah. Maybe that's why. I don't know. But anyway, we'll just have to go with the flow here. All right. So, but now look, this one says works, but now if works, this works is another what? Functor of a predicate. Yeah. Okay. And then works, and this is where he works and how much he makes. Right? And then, but on the other hand, it could be, you could have just be unemployed, unemployed, unemployed. These are all lowercase, and so it's easy just to type this in. Now, does everybody see how this represents a family with this relevant data? And the interesting thing is going to be, how do we query it? Now look, on this figure 4.2, check this out. Do you see then that this tree represents, well, if this tree matches something in the database, what will it match? It will match any family that has what?
The last name Armstrong.
The last name Armstrong for the husband. Are you with me? And all these others, doesn't matter. So this will match any family that has Armstrong for the second name for the husband. What will this one match? Any what? Any husband, any what? Yes, any husband, any wife, and then any 3 children. So this structure will match any family that has exactly 3 children. Are you with me? And furthermore, what will this one match? This C, what will this match? This will match the what? All the families whose what? What's the second one here? Whose what? Wife has what? Name. This is a variable now. Capital name, capital N name, and what? Capital S surname. So what? So this will match. Oh, but also what? I guess also 3. Is this also 3 children?
Yeah. So it'll give the name of a mother with 3 children.
Yes, this will give the name of all the. Well, that's a good question.
That's true, because the other one could be.
Did I?
It could be a mother with children.
No, would this be at least?
At least.
This would be at least. Yeah, this would be at least. Is that what the caption says?
It just says wives.
Well, yeah, but I think that would be at least, yeah. Okay, you guys, now, watch this. So what we're going to do now is, okay, so in our demo, you see this is that family that we just saw. Now, unfortunately, I don't want to have to go back to that slide all the time, but here it is in ch4.pl. Now look, first of all, here is the definition of, or here is a predicate that we can use to see who the husbands of all the families are. So husband, so do you see this rule? Husband X if what? Family X, any wife, any number of children. Are you with me? So how would we query all the husbands? What query would we write to get all the husbands of all the families? To list all the husbands of all the families, what would we say? Yeah, exactly. We would just say husband X. So look, now these queries can get kind of long, so I've put them. I'm just going to copy paste, and this file is available for you to download. Okay. So if I do husband X, what's going to come out? Will it come out, Tom? What will come out? Because X will match what? The whole person. Are you with me? Now, does everybody see that? X is matching that whole person structure. Is everybody with me on this? Okay. And now, what's next? X is a wife. So how are we going to? How will we define wife? Obviously. Yeah. So wife X if family like X. Okay. And so we could do all the wives. So what's our query for all the wives? How do we do? Wife X. So here, let's try that. Now, I only have one family in the database here. And sure enough, is everybody good? So that, but again, what got matched was the entire person, right? And how about all the unemployed wives? Now, do you remember how that worked? What has to match? Which one of the person? 1, 2, 3. The fourth one of the person has to be. Yeah. So how do we query all the unemployed wives? Wife. Wait. Say that again. Well, first of all, when we did wife X, what did we get? We get all of this. But now we just want the ones that are unemployed. We don't have a big database here.
Do we want to get back the actual person or just the name?
Let's just do the persons. Oh, wait. No, let's do it better than that. Let's do the names. I guess I should have said names of all the unemployed wives. Because now, what will wife, wife X, what matches the person, but now we're saying wife, and then that person is going to match person, and so now, are you with me? So what will this be? What will this give us? And surname equals, right? Surname equals Fox. Is everybody good? So you're right. We wanted the name, not just the whole person, right? And so how would we do if there aren't any employed wives in this database? There are in the one that I'm giving you for your homework. So what would that query be? Obviously. Oh, well, maybe not too obvious. What would it be? How would we query that?
That same thing, except instead of unemployed, it would be works.
It would be works what? Except instead of unemployed, it would be what?
Job. Is that a salary?
What do you want when
No, you just want the name of the employed wives.
Works,
Blank,
blank.
Yeah, but it has to match the word, yeah. Yeah, are we good? Now, if I do this, it's not going to succeed because I only have this one family in the database. But anyway, that's how you would query it, all right? Now, how about X is a child? Ooh. But now what about the children? That's a what? List of children. So what? Huh?
Blank.
Child X if family blank blank what? Matching anything for the husband and wife. And then what?
Would be bracket blank.
Why don't we just make the next one be a variable? And what will it match to? A what? A list. Are you with me? Okay, so family, blank, blank, capital C children. That's a variable that's instantiated to the list. And now what? Didn't we use a previous predicate that would come in handy here? Come on.
Insert or something.
No, we don't want to insert. We want to know if it's a what. If what is a what of what.
A member.
Yeah, member. Don't we have member?
Member X children.
Yeah. Member X children. Are you with me?
Is that built in?
Yeah, member is built in. We did my member, but member is built in.
So every child, we're finding out if a specific name is a child. We're not
Me-
listing the children, we're finding out if.
Well, this is the definition of X is a child. Are you with me? Now, we haven't done a query. So now, how would we do a query? Okay, so how would we query all the children? We would say what? Yeah, child X. That's all. Look, I won't even copy paste it. It's so short. So let's do, maybe I should have copy pasted. Okay, check it out. And now, that's that person, the first child, and now it happens if I press semicolon. Another one, yeah? The children of the list, because that's how member works. Are we good? Isn't this powerful? Isn't this a slick paradigm? How about this? How could we get all the people? Notice I say query attempt.
Yeah.
So how could I get all the people? I mean, what would be kind of a natural thing for you to think?
Blank, blank.
Well, I mean, go back to the thing.
You could do
Oh, family.
multiple rules.
Well, yeah, see, you guys are too smart. You're not falling for this. You know, what would happen if I did person X? What's the problem with person X?
Because person is more than one.
You need to personally nest it within.
Yeah, person is not, there isn't a person,
Not like a fact.
it's not a fact. Yeah, okay. So look, if I do this, that's an existence error, right? Because there is no person rule. So here's what we're going to do. Any person in the database, we're going to say exists person. But now look, we already defined husband and wife and child, did we not? So exists person if what?
Husband or
Husband what? Person. And then how do you do or? There is a way to do or without having a separate rule. Remember? Semicolon, what? Wife person, semicolon, what? Child person, boom, okay? So now how do we do any person in the database? All the people, so how do we query all the people? Exists P. So now if we do exists P, what happens? Look, and notice that what P is getting instantiated to. The person. Are you with me? Boom. There's the husband, there's the wife, there's the child, there's the other child. Is that cool? So anyway, I have actually this revised ch4.pl file that I uploaded. you know, that I'm going through now, it's available for you to go through. And we'll go through it, we'll continue going through this next time. And when's your next homework assignment due?
Thursday night, well, tonight and then Thursday.
Oh, Thursday, tonight because of the extension. And then, but, you know, I'll continue to go through this next time, but it's available for you to go through if you want to get started on your homework. All right, is the battery still running? Oh, excellent. So we had enough power to finish. Oh, thank you for reminding me. So, see you next time.